Welcome back. Time for 9.5, which is a section titled Natural Logs, Natural Logarithms. There are two very special logs that we talk about. The first one we saw in section 9.4, it's the common log, log base 10. But what happened was mathematicians and scientists kept noticing this other base pop up again and again and again in nature. And that's what they named the natural log. Now, what is that base? The base of the natural log is E. And yeah, what is E? Well, you can see here, E is not a variable. It's kind of like pi in the sense that it's a symbol that refers to a very well-known number. I'll show you where it is on the calculator. So right below the log button, you can see ln, and you can see above it for that second blue functionality, e to the x. If I say, what is e to the first power, just to see what e is? 2.718281828, and it doesn't continue just with the eights you can see on the one note. It's just a number that's 2.718-ish. So this number kept popping up over and over and over and over again. And so scientists and mathematicians got together and said, you know what, there's something to it. We're going to call it E, and we're going to make it the base of a special logarithm called the natural log. So taking a look right here, that's kind of your history lesson on this. I'll go right here. Natural log is log base E of x, but you will almost never see it written like this, log base E of x. Instead, you will see it written as ln of x. And if you're wondering why it's ln and not nl, it's Latin, Logarithmus naturali. And so ln of x is the natural log of x, log base E of x. Just like any log and its base, ln and e function and kind of cancel each other out. So if we're looking at the equation on the left, ln of x equals e, how do I cancel out an ln? I am going to e to the left equals e to the right. We've seen this before. Taking the base and saying the base to the log equals base to the other side, and e and ln cancel out. So we're left with just x equals e to the 99th power. That's how you cancel out an ln. What if you start with an e? On the left, well, we're going to get rid of that e, I'm going to take the natural log of both sides. Ln of e to the x equals ln of 12. And I want to show you what happens with the power property that we already know. X comes down to the front. X times ln of e equals ln of 12, but ln of e cancels out, so it's just x equals natural log of 12. So that's how you can cancel out an e if you start with an e using natural log. So we can rewrite, and this is a common thing you'll be asked to do, is just rewrite equations in either logarithmic form or exponential form using ln and e. So on the left, ln of x equals 99. I know I'm just going to hit both sides with an e, and I know e to the ln of x is going to cancel out. So e to the left equals e to the right, and I know we saw the answer to this above. I'm just showing you kind of that quick thinking of how you can think about it. That goes from logarithmic form with a log to exponential form with an exponent. How about the other one? We know we can go ln of the left equals ln of the right. It'll cancel out x. X equals ln of 12, just like we saw above. And we went from exponential form, something with an exponent, to logarithmic form with the natural log. So when you see problems that just say rewrite using exponential or logarithmic form using e and ln, this is what they're talking about. They're just saying if it starts with ln's, get rid of them and have e's in the final answer, and vice versa. So We have a handful of problems right here. Rewrite the following equations in either exponential or logarithmic form. I will do the first two, and then I want you to try the second two. First one, ln of x equals 10. I'm going to say, well, I know I'm going to hit both sides with an e. E to the left equals e to the right, so x equals e to the 10th. And the one right below it, e to the x equals 1098. I got to get rid of that e. I know the key to doing that is to take the natural log ln of both sides. I know it'll cancel out on my left. X equals ln of 1098. Pause the video, try the two problems on the right, and then unpause to see if you got them right. All right, so this is something you want to be able to do just without even thinking of it. On top on the right there, ln of both sides gets rid of the e, so x equals ln of 42. And on the bottom right, x equals e to the 6th. We said e to the left equals e to the right, e to the ln canceled out. So hopefully those went well. If not, take a look at where you might have gone astray and see if this makes more sense. All right, so now let's get to actually solving equations, because that's what a lot of algebra is about. 3 times e to the negative 2x plus 4 equals 10. We need to find an x value that makes that true. So step one, I know I'm going to use ln to cancel out the e, but I have to get e by itself first. So I'm going to start by subtracting 4. So 3e to the negative 2x equals 6. Still trying to get e alone. I'm going to divide by 3 on both sides. E to the negative 2x equals 2. And now that I've gotten e just by itself there, now I can take the ln. So I'm going to say ln, the natural log of the left, equals natural log of the right. Natural log of e cancels out. Negative 2x equals ln of 2. Divide by negative 2. X equals ln of 2 over negative 2. Now, most of the time, you will see answers left in this form, just in the form of the natural log. We could type it into a calculator and find it out. Ln of 2 divided by negative 2. You can see that's negative 0.3466. X is approximately negative 0.3466, I think I said. And so you can write it, as a decimal, as a numerical value, but most of the time you will see it just left on the way it is on the left there. Natural log of 2 over negative 2. I want to check that real quick. I'm going to store that in x and say 3e second ln to the negative 2x plus 4 equals 10. I know I did it right. So it looks a lot like algebra problems we've worked before. Subtract 4, divide by 3, get e alone, and then use ln to cancel it out and solve from there. I would like you to try, well, no, I'll do this one, and then I'll have you try the next two. So 4e to the negative x. I lied. We just did an e problem. I want you to try this e problem. So I'm going to pause the video, work it out, and unpause it. We just did an e problem, so if you need to, reference the work on your page already to solve for x in this problem. And here's what I got for that problem. Again, add 9, divide by 4, take the ln, and then that gives us negative x, so divide by negative 1. I got x equals negative natural log of 7/4. So I'll pause here and just point out, again, most of these steps are kind of algebra 1, algebra 2 steps that we've already seen. How do we get e alone? And then once we have it alone, use the natural log to get rid of it. That's kind of the biggest new thing here. You can see I checked my answer on my calculator as well. All right, let's do this one real quick. Let's do one where we start with ln, and we're going to need to use e to solve this. 18 times natural log of x minus 4 equals 7. Now we're trying to get natural log by itself so that we can e to the left equals e to the right it. So step one, I'm going to divide by 18 on both sides. So natural log of x minus 4 equals 7/18 now. Okay, to get rid of ln, I'm going to say e to the left equals e to the right. So e to the ln of x minus 4 equals e to the 7/18. And of course, e to the ln cancel out. That's the whole reason we did that. X minus 4 equals e to the 7/18. X equals 4 plus e to the 7/18. And again, typically just leaving it like that. I'm going to make that 8 look a little better. And I'm going to check my answer. 4 plus e to the 7/18. That's going to be not like a nice whole pretty number. It's 5.4753. If I plug that, store it as x, and then plug that in, 18 ln of x minus 4, it does indeed equal 7. So again, 20 seconds later, I know for sure I got this problem right. Divided by 18 to get ln alone, and then used e to get rid of the natural log. I want you to just try this one. This one's a little bit even quicker because the ln's already alone. So try this one out and then unpause to see if you got it right. And on this problem, I ended up with x equaling e squared over 9. Remember, e is just a number, so e squared, we could type that into a calculator. I did to check my answer. E squared divided by 9 was 0.8210, and when I plugged that back into my original, I did indeed get 2. So using e's and ln's to kind of counteract each other, e's and natural logs. This doesn't only work with equations, as you probably guessed. What about inequalities? You might recognize this. This looks pretty familiar to an equation we worked above, but I'm going to subtract 4 on both sides. 3e to the negative 2x is greater than 6. Divide by 3. E to the negative 2x is greater than 2. I'm going to take the natural log of both sides and say that negative 2x is greater than ln of 2. Divide by negative 2 and x. And let's see if you caught that trick. I was trying to rush through it a little bit. X is less than ln of 2 over negative 2, because we divided by a negative, right? We've seen that before many, many, many times. It's not anything new. Ln of 2 over negative 2, again, exact same answer as when it was an equation, which makes sense. It's just that now we have an inequality sign on there. What about on this one? Again, we have a less than or equal to start. So I'm going to say 4e to the negative x is less than or equal to 7, adding 9 to both sides. E to the negative x less than or equal to 7/4. I know I need to take a natural log to counteract the e, so I'll do that on both sides. Natural log of 7/4. X negative natural log of 7/4. And what is the sign? Greater than or equal. But the biggest point, I know I'm kind of harping on that flip the sign when you divide by negative. The biggest thing is just these same steps work for inequalities as well. Okay. So with that being said, we've covered most of what we wanted to and needed to for natural logs and e. What I want to do here is show you a couple places they do show up in science and the real world. And this will be a perfect segue into 9.6, because 9.6 is all about these types of problems. So the first couple have to do with banking. And for banking, we have this equation written at the top there. A equals PE to the RT, PERT. And what that stands for is the amount of money you currently have equals the principal, which is how much you started with, times e to the rate times time. The rate being your interest rate maybe, and time being how long it's been in the bank. So A problem like 43 says if you deposit $100, that's my principal, that's what I'm starting with, in an account paying 3.5 interest, that's my rate, compounded continuously, that's how we know to use this equation. Continuously means use this equation with an E. How long will it take for your money to double? So for 43, and that's the only one we're really looking at here, I won't work out 44, although you can look at it if you would like. Amount equals principal times e to the RT, to the rate times time. I know the principal is 100. I know 3.5% is my rate, so I'm going to write that as 0.035. It says how long will it take, so I know I'm solving for t, but what is my amount? Well, they don't have a dollar sign by it, but they do tell us. They say we're waiting for our money to double. If we start with 100, doubling will have happened when we hit 200. Try pausing the video and solving this, and then I will wait and then work it out. So I won't just work it out off screen. I'll work it out on screen, but try solving this for t. See what you get. All right, if you're back, I'm assuming and hoping you've tried to solve this. I'm going to write it out over here. 200 equals 100 e to the 0.035 t. Divide by 100 on both sides, we get 2 equals e to the 0.035 t. Take the natural log of both sides, right, to get rid of the e. So I'll show that. Natural log of 2 equals natural log of e to the 0.035 t. Natural log and e are gone. So natural log of 2 equals 0.035 t. And then final step, divide by 0.035 on both sides. Now, I know I just got done saying we'll usually leave it in natural log terms and we won't always get an answer. But in this kind of problem, a real world problem, and someone asks you, how long will it take for my money to double? Telling them, oh, natural log of 2 over 0.035, that doesn't do them much good. They probably would want a number. So when it's like a real world problem, I will go ahead and plug this in and say natural log of 2 divided by 0.035. It'll take about 19 years, almost 20 years, for that money to double if it's never touched. 19.8042. 8042 years. So again, a nice problem here. We're not going to work 44 on screen, but you can look at it if you're interested. A nice problem here showing E and ln in the real world, how we can solve equations with them. One more. You start with 100 grams of a certain substance that decays according to this equation. I'm going to highlight it in yellow. Y equals AE to the negative 0.0037 t, where A is the starting amount, T is the time in days. How long will it take for 3/4 of the substance to decay? Well, if 3/4 decays, and we started with 100 grams, so that means 75 grams decayed, and how much do I have left? Well, if I started with 100, I have 25 grams left. So Y equals AE to the negative 0.0037 t. Y is how much I have left at any given time. So I'm going to say 25. A is my starting amount, 100. E to the negative 0.0037 t. At this point, I would like you to pause and work it out. I am going to pause and work it out. We'll compare our answers at the end, but I want to know how many days, what is the value of t? How many days will it take for 3/4 of this substance to decay? And based on my work, I'm getting approximately 374.6742 days. All my work is on the screen there. You can compare it to your own, see if it matches. Ended up kind of final answer in terms of logs, t equals negative natural log of 1/4 over negative 0.0037. I might have said negative twice there, I'm not sure. Natural log of 1/4 over negative 0.0037. So just some practice with e's and ln's, and you have some practice problems assigned. Take a look at them, get that practice, make this muscle memory, see if you can figure out these e and natural logs, that relationship, and how to solve these problems with them. If you have questions, obviously bring them next time, contact me, let me know. Otherwise, I will see you in our final section in chapter 9, 9.6.